Okay, so good morning, dear students. Now we are going to do some examples related to design of NFA. And we know in automata theory, so automata is of three types basically. So first is DFA, then we have NFA, then we have epsilon NFA. So last time we did the questions related to design of DFA. So DFA is deterministic finite automata and NFA is non-deterministic finite automata, and similarly this is epsilon non-deterministic finite automata, and epsilon is related with the empty string. Remember, epsilon means empty string when the length of the string is 0. So this thing we have to remember. Epsilon means empty string. Now NFA, what is the difference between DFA and NFA? In DFA, every state must respond to input symbols. So every state must respond to all input symbols. This is the condition in that is we deal with DFA, design of DFA. That's why we have to complete the diagram. But here in NFA, there is no such condition that every state have to respond to input symbol. So there is an option like, so the state can or state may or may not respond to input symbol. The state may or may not respond to every input symbol of the sigma. Like here, the sigma is set of states and which is equal to a comma b, set of two symbols. Now by this definition we have the every state must respond to a as well as b, but for NFA that's not required. So this is the basic difference between DFA and NFA. Secondly, in NFA the delta transition from a state q naught with input suppose a, this may going towards either state q1 or either state q1 q0 or q1. So this is the basic difference. In diagram you can see the same thing. We have q0 state and we have q1 state, but with the same input a, you can see this one, with the same input a we are able to move at the q0 as well as at the q1. So this kind of non-determinism is available in the NFA, whereas the DFA only from one state to move to the another state with the help of input symbol a, or with the help of one input symbol we can only move towards the another state or only move towards the one state, but we are not capable to move towards the two or more states with input symbol 1. So there is kind of non-determinism available in the NFA. Now let's do some examples related to NFA. So this is the basic difference as per the definition of NFA. So now we are going to learn some examples related to NFA. So as per this question, design of NFA over sigma AB such that the accepted string start with AB. Though this is start word is there, so we know from the DFA when start kind of condition is there, so we have dead state also in the diagram. But in NFA there is no need to add any kind of dead state, and we will learn this with the help of example. Now you can see start from the initial state, that is q0, with input symbol a we can move to q1 with input symbol B, we can move to Q2, and this is the uh, final state, because for this type of language AB itself is the minimum possible string. So when we get A and B in this sequence, we are at the final state, which is Q2. Now this, after this Q2, there can be any number of A and B combinations, or any number of A can be repeated, any number of times B can be repeated, because we have satisfied the condition, that is the accepted string start with AB. So this has start with AB. After this you can have this kind of strings, you can have this kind of strings, you can have this kind of strings, you can have this kind of patterns. So what is common in these examples? AB is the initial string at the start string, so string should be started with AB. Now what happen if B is the first, if B is the first input symbol, it means that string is not going to be accepted, and we are not entering any kind of dead state here. This is possible with the NFA, and basic difference between the DFA and NFA you can observe. If we have to do the same question with DFA, so this is the example for NFA. If we have to do the same question with DFA, then we have to complete the diagram like in previous videos. Up to this is NFA. Now we are making it DFA so that we can compare the two, NFA and as well as DFA, with the help of same example. Now we have to complete, in case of DFA, we have to complete the diagram. This is the important part in case of DFA. So how to complete means, what happen if B comes here? So if B comes here, we have to create another state, that is Q3, and that is going to be a dead state. That's why any number of A and B can be repeated, but that remains at the dead state. Similarly, what happen if A comes here? So A, it means the pattern is disturbed, we need only AB. So if A comes here, we have to transverse this one into dead state. So this is the final diagram for DFA. For the same example, now you can observe the difference between NFA and DFA. NFA, there is no need to add any dead state. In NFA, there is no need to add any dead state, but whereas in DFA, we have to complete the diagram, and any state, every state must respond to both symbols, A as well as B. Here Q0 only responds to A, not to B. Similarly, Q1 responds to B, not to A. So we don't bother about this one. So that's all for this example. I hope you are able to understand the NFA as well as the difference between NFA and DFA with the help of same example. Thank you.